So we are going to look at the URL frontier now in more detail. So imagine zooming into this particular box. Now recall that there were two things that we wanted. I mean, among many desirable features, there were two desirable features called politeness and freshness that we wanted the crawler to satisfy. What was politeness? The crawler should not hit a web server too frequently. And what was freshness? Freshness refers to the fact that the crawler may have to recrawl some pages that it has crawled before. And moreover, it may have to recrawl some pages at a different rate from the rate at which it would recrawl other pages. So some websites, say let's say some news websites, may have to be crawled very, very often. But other websites, for example, the websites of say students at a particular university, they may have to be recrawled, but not at a very uh, not at a very high rate. Maybe once in a few days instead of once every hour. So if you were to implement the URL frontier as a simple priority queue, now I think we talked about priority queues earlier in this course, but I'm assuming that it's something you did earlier in your data structures course. Uh, for now, you can just ignore the word priority here. Just imagine a queue. One of the problems with implementing the URL frontier as a simple queue would be that it's possible that there could be many links out of a page going to its own site. So for example, www.cisco.com could have many links going to other pages on that same server. So what would happen if a crawler started to crawl cisco.com, and let's say that's the first website that it's crawling, even if it's not the first website it's crawling. When it crawls cisco.com, it's going to take all the URLs that are located on that website. Now, cisco.com may not have many URLs, but it's possible that there could be other pages which will have a huge number of URLs to other pages on the same website or on the same web server. So all those URLs will get inserted into the queue together, right, one after the other. This means that if they were inserted together, there will be a point when they will be taken out of the queue together, because queue is first in, first out. So the order in which they were inserted is also going to be the order in which they would be taken out. Now, if the different threads running on a single machine, if the different crawler threads running on a single machine were to all be given, or be if they were to be handed over all these URLs together by the URL frontier one after the other, then all these threads will be simultaneously bombarding that particular server, cisco.com. Right? So you want to space apart your fetch requests to any web server. You don't want to take a large number of contiguous URLs pointing to the same web server and then have all these threads suddenly send a burst of requests to that web server. So you want to be polite. You don't want to hit a web server too frequently, but at the same time, you also want to crawl some servers again and again. So how do you achieve both these goals? One of the ways in which politeness is handled is by hitting the server repeatedly, but spacing apart those fetch requests by a relatively long time gap. And one of the common heuristics used is that the time gap after which I will send the next request to the same web server has to be at least, say, 10 times the last uh, latency, the latency of the last request, from that server. So let's say the last time when I sent a fetch request to the server responded in 1 second. Then I'm going to ensure that I will send the next fetch request to this server after 10 seconds. I won't send, so as soon as the web page, as soon as the server returns a web page, I won't immediately send the next URL to the server. If I'll hold off for 9 more seconds, and then after 10 seconds are over, then I'll send the next fetch request. That's that way I'll be polite. Now we are going to look at the architecture of the URL frontier in some detail. And the first diagram that actually I want to look you to look at is this diagram from the book. I just want you to visualize the entire architecture in a single diagram before we look at the pieces. So what is this diagram? Basically, this is the input to the URL frontier. So basically, if you go back to that slide, so this is the input to the URL frontier. A URL is going into the URL frontier. And let's look at the path that the URL will follow. It goes inside the URL frontier, and this URL will enter one of these front queues. So what you see over here are a set of queues. These are called the front queues because these are queues that are present at the front of the URL frontier. I mean, these are the queues that the URL will immediately encounter upon entering the URL frontier. And as you can imagine, there'll be another set of queues called the back queues. So what the URL will do is it will get put into one of these front queues. Okay, let's not worry about what these front queues are and how it will be put. I'll just explain all that. But just imagine this URL going into one of these front queues. It's going to follow this path, and then at some stage it will be pulled out of the front queue and then sent into one of these back queues. And then at some stage it will be pulled out of the back queue and then sent out to the crawler thread. Okay, that means it will be at some stage it will be pulled out of the back queue and sent to the crawler thread, which will then go and actually fetch the document at that URL. Okay, so I hope you can now follow what is going to happen.